As the title suggests, in this ShowMe I'm going to introduce two important properties related to division surrounding exponents. The first property we're going to talk about is what happens when we divide two powers of the same base. The other property we're going to deal with is the property of the power of a quotient. So here's the situation we're dealing with first. We're dividing two powers that happen to be of the same base. The result of this division will be a to the m minus n power. That is, all we really have to do is subtract the exponents. To see how that works, let's walk through the process using properties we already are quite confident about. First of all, if we're going to have a to the m power divided by a to the n power, we know that division is really multiplying by the reciprocal of the divisor. So we can rewrite that division as a product, a to the m power times 1 over a to the n power. Still means the same thing, but now we can play with it a little further. In our first work on exponents, we learned about negative exponents, and we know that we can rewrite 1 over a to the n power as a to the negative n power. So now we've returned to that original situation. We've got two powers of the same base, and we're multiplying them. Well, if we multiply two powers of the same base, we add the exponents. So that becomes a to the m plus negative n power. Finally, we know that adding a negative is the same thing as subtracting, so what we really have is a to the m minus n power. That sequence of expressions demonstrates the connection between properties we'd already learned about and this new property that we're going to have to master in this section. It's not going to be very hard, but it is important to see the connections. In fact, with a slight reworking, we wouldn't actually need to have two different properties. But for the introductory student, it's helpful. It's awfully hard to remind introductory students all the time that there really isn't anything called subtraction. It's just addition of the opposite. And it's really hard to keep reminding them that division is just multiplying by a reciprocal. Easier for the teacher and for the textbook writer just to give them two properties to play with. Now it's time to explore the most important question in math class, which is, so what? What are we going to use this for? Well, let's take a look at this problem done the old-fashioned, hard, long way. Well, 2 to the 8th is 2 times 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 2. Whereas 2 to the 5th is 2 times 2 times 2 times 2 times 2. Well, we know that these two numbers have a common factor, a greatest common factor of 2 times 2 times 2 times 2 times 2. So we can divide that factor out of each, like so. Now in doing that, we've canceled out every single factor in the denominator. Whenever that happens, the placeholder is a 1. So now we have 2 to the 3rd over 1, which is 2 to the 3rd. What does that tell us? Well, our property works because 2 to the 3rd is 2 to the 8 minus 5. So we really don't need to go through all this work ever again. From now on, we simply go from 2 to the 8th divided by 2 to the 5th straight to 2 to the 3rd. Just subtract those exponents. Then, of course, the final answer would be 8. Why do we go through all that? So that we'll never have to do it for that kind of problem again. Of course, to most beginning students, this looks like a completely different kind of problem, even though it really isn't. Let's march through it quickly and see how it should look. Well, 5 times 5 times 5, divided by 5 times 5 times 5 times 5 times 5 times 5 times 5. As before, we can divide out a greatest common factor, but this time that greatest common factor is equal to the numerator. So we divide 5 to the 3rd power out of each, the numerator and denominator. Of course, everything in the numerator canceled, so we're left with a placeholder of 1. So now we have 1 over 5 to the 4th, which we know from our work with negative exponents is 5 to the negative 4. And that means, of course, that we didn't have to go through all that, and we won't ever do it again. We just could have taken 3 minus 7 to get 5 to the negative 4. So from now on, all we do is subtract the exponents. I promise. So, let's play. Well, Here we have two expressions, and we can use our new property of exponents to simplify things. We have m to the negative 2 in the numerator, m to the fourth in the denominator. That's going to be equal to m to the negative 2 minus 4 power. In the same way, we can subtract the exponents involved with the n's. It's important to remember that when you see an n by itself, as in the denominator here, we really have an exponent of 1. So n to the third divided by n to the first is n to the 3 minus 1. So simplifying these two differences, we have m to the negative 6 times n squared. A perfectly reasonable answer, except that, as mentioned in previous ShowMes, in some courses, including my own, you're not really done until all the negative exponents are gone, in which case such a course would prefer an answer like this. To me, they're both equivalently equal. In either case, you demonstrated that you can use the property. However, make sure you're adapting your performance to the expectations of either your course materials or your teacher, or both. Let's play one more time just to make sure that we've got it. Again, in the denominator, you see x without an exponent. Whenever you see a variable without an exponent, it has an exponent. That exponent is 1. So here we have x to the 3 minus 1 power times y to the negative 2 minus 5 power times z to the 5 minus negative 2 power. So we have x squared times y to the negative 7 times z to the 7th. A perfectly excellent answer in my opinion. However, if your book or instructor requires it, you may need to get rid of the negative exponent, in which case your perfectly good answer is x squared z to the 7th all over y to the 7th. The negative exponent powers have to move to the denominator if you're going to eliminate those negative signs. Well, throughout this process, we've learned to add, subtract, and multiply numbers in scientific notation. We haven't divided them yet. Well, now it's time. To do this problem properly, we consider it as a product of two quotients. The first quotient is 2 divided by 8. The second quotient is 10 cubed divided by 10 to the 8th. Well, 2 divided by 8 can be expressed as a decimal as 0.25. And 10 cubed divided by 10 to the 8th, subtract the exponents, and we have 0.25 times 10 to the negative 5. Now that's not in scientific notation, but the number we started with were. So it's important that we should return our answer to the same form as the numbers that we received when the problem was proposed. Well, to fix this, we've got to create a first number that is greater than or equal to 1, but less than 10. To accomplish that, we need to rewrite that as 2.5. What we effectively did was to move the decimal point one place to the right, making the number 10 times bigger. Well, if we're going to make this part of the number 10 times bigger, we're going to have to make the other part of the number 10 times smaller. And what number is 10 times smaller than 10 to the negative 5? How about 10 to the negative 6? And there's your answer. So now we know how to divide numbers in scientific notation, and our basic arithmetic for them is complete. One more time, just to make sure we've got it. First, rewrite this as two quotients being multiplied together. 4.5 divided by 1.5 times 10 to the 11th divided by 10 to the negative 5. Now 4.5 divided by 1.5 is 3. And 10 to the 11th divided by 10 to the negative 5 requires us to subtract the exponents. 11 minus negative 5 is just like taking 11 plus 5, so that's 3 times 10 to the 16th. So that's how we handle dividing powers of the same base. And that's how we use it in a particularly important application, because you're going to find yourselves doing a lot of calculations in chemistry and science class, and possibly astronomy or even biology class, where you're working with numbers that are in scientific notation. Now for our last new power for exponents for this particular chapter. If you take a quotient to a power, that is equivalent to taking the dividend and raising it to that power, and dividing that by the divisor. raised to the same power. Effectively, if we take this and apply it to 2/3 to the 4th power. Well, if we didn't have this little property, what would we do? We would take 2/3 times 2/3 times 2/3 times 2/3. Well, we know that when we multiply fractions, we multiply the numerators together, we multiply the denominators together. The effect of this, then, is that we would take 2 to the 4th power and divide it by 3 to the 4th power. We don't need to do this anymore. We now know what will happen. 2 to the 4th is 16, 3 to the 4th is 81. Notice, and this is important to remember, whenever you multiply a fraction that is less than 1 by itself for a set number of times, you end up with a number that is much smaller. In the same way, if the fraction were even just slightly greater than 1, if you raised it to a power, it would quickly grow far beyond 1. That's important to remember when you get into compounding and exponential applications, and those will come forward someday. So let's put this wonderful new property to work in dealing with our various powers and situations that are coming up. Well, in this situation, we're supposed to apply the cube power, the 3rd power, to the numerator and to the denominator. So on top, we'll have x cubed. On the bottom, we'll have y squared cubed. That causes us to call upon a recently learned property about the power of a power. On top, we're still going to have x cubed, but in the denominator, we're going to have y squared cubed. In that situation, you should multiply the exponents, so we'll have y to the 6th, and now that simplification is done. This one is to be done in much the same way. It's a little more interesting because one of the numbers involved, one of the bases involved is known to us, so we'll have some calculating to do. Still, not a whole lot has changed. We've got t to the 5th, it's got to be squared. And we have 3 to the 4th, and that's got to be squared. Well, t to the 5th squared is t to the 10th. We're supposed to multiply those exponents, and that's what I did. 3 to the 4th squared, again, you multiply the exponents, you end up with 3 to the 8th. Now, t to the 10th, not much can be done with it. But 3 to the 8th, 6,561. And that's the answer. Notice each time we simply apply the power to both the numerator and to the denominator. In a couple of cases here, we've had to use other powers to finish the job. That will be more and more commonplace, and we're going to learn a lot more things to do with exponents before this course is over. It gets a little bit trickier when we're dealing with negative exponents. We can take the long way around this problem, and it'll look like this. Our rule says that the numerator and the denominator each have to be raised to the -3 power. So we follow the rule. We have 3 to the -3, and that's divided by 4 to the -3. Well, we know what negative powers mean. They mean that the power is actually supposed to end up in the denominator. So here we've got two fractions to deal with. The fraction in the numerator of our original fraction will be 1 over 3 cubed. The fraction in the denominator of our original fraction will be 1 over 4 cubed. Now when we divide fractions, we know that we're supposed to multiply by the reciprocal of the divisor. So we're going to take 1 over 3 cubed, we're going to multiply it by the reciprocal of the divisor, which is 4 cubed over 1. So we're going to have 4 cubed over 3 cubed. And just to complete the circle, the answer would be 64/27. But I want you to take your gaze one step back and really focus on what's going on here. We can get there from our beginning point without going through all the work in between. How? Well, let's go back and reconsider this problem in a different light. We have 3/4 to the -3 power. Using our power of a power property, we can break that -3 into two parts. One part would be -1, the other part would be 3. We would write it this way. We'd have 3/4 inside the parentheses being raised to the -1 power. And then once that was done, we could cube the result. That would still be the same thing as 3/4 to the -3 power. That is what it says in our power of a power property. Why would we do this? Well, we've learned before that when you raise something to the negative 1 power, you're discovering its reciprocal. So 3/4 to the negative 1 power is 4/3. Now that's much better. Now we only have one positive exponent, which we can quickly apply to each number. We'll have 4 cubed over 3 cubed, which takes us right back to our result, 64/27. We don't really need to write this step either. All we really have to do is whenever we have a negative exponent, and we're doing this to a base that is a fraction, the first step is simply to flip the fraction and drop the negative sign out of the exponent. Once you've done that, you've still got an equivalent expression, and it's so much easier to do. So let's make that our practice. So let's apply that concept to this problem. The very first thing we should do is take the reciprocal of the number inside the parentheses. It was negative 1/2, now it's going to be negative 2. But now that we've taken the reciprocal, we don't need a negative sign on our power anymore. So we have negative 2 to the 5th power. Well, we have a negative number raised to an odd power. The answer is going to be negative. And 2 to the 5th power is 32. I really think that's the best way to tackle a problem like this. Finally, let's do a negative power of a quotient that has some variables in it, just to make sure we understand what happens. Remember about variables. They're numbers. We may not know what they are, but as all numbers, they follow rules. And so this A and this M, they'll follow the same rules we were just using. The very first step I've advocated is that you should take the reciprocal of the number inside the parentheses. Simply start there. And remember that once you've done that, you no longer have a negative exponent, because you've taken care of that part of the power. Now it's a matter of squaring each part. We're going to have m squared on top. On the bottom, if we square a product, we're going to have the square of each factor of that product. So it becomes 7 squared a squared, which then simplifies to m squared over 49 a squared. I want to emphasize again, these two properties really don't make anything new happen, but they do give you a clear first step, a clear starting point and process to follow when you see certain kinds of problems. If you're going to use all these properties as I've shown them to you, then it's important that you practice them and memorize the starting points that call for them and the different steps. Especially pay close attention to what happens when negative exponents get involved. They're still relatively new to you in your study of algebra, and it's important to avoid silly little mistakes. I hope this helps, but if you encounter some problems that give you a lot of trouble, don't hesitate at all to contact me through my blog at mypoliquin.com. There's an email link on one of the pages for homework help. Send your problem there. Describe it as well as you can. If there's a reference online for it, let me know where to see it. And I will write up a blog post. I'll keep you anonymous, and I'll give you all the help I can to help you understand. Remember, the motto of that blog is making sure everybody gets it, and that's exactly what I want to help you do.